integration by substitution. All right. Now, for the earlier methods that we've done until now, we've talked about integrating fractions using a number of different methods. We've talked about integrating products using integration by parts. You mostly have to figure it out yourself what type of method you're going to be using for integrating a function. However, substitution is one concept that you have in your syllabus in which they will always tell you that you have to use substitution. Okay, so you won't have to think about it. They will always tell you that if you have to use a substitution in some situation, they will tell that you have to use the substitution. Okay, so let me just write that down here. It will always be given in the question. It will always be given in the question. If you have to use a substitution. Okay, so you won't have to think as much about this. They will always tell you. And they'll also tell you what substitution you have to use. So you won't even have to think about that. So they'll tell you that this is the problem and this is the substitution that you have to use for this. Okay, for example, let's say you have something like this. Let's say you have to use a substitution. Use a substitution. U equals sine of x to find the integral of sine x into cos x with respect to x. Okay. Now, this is something that you could use, this is something that you could integrate using integration by parts as well. Sine x into cos x, it's a product. You could try integrating this using integration by parts. For this, however, you'll have to use this idea that we did at the end in integration by parts. It would be a recursive thing at the eventually, because you'll get, when you integrate this sine x cos x using integration by parts, in the integral you'll get sine x into cos x again when you use integration by parts. So you'll then replace that thing with I like this, remember, and then integrate using this method. Okay, so this is something that you could do there as well. However, another way of integrating that particular function that they wrote there is substitution. You could do this using integration by parts, using what we discussed earlier as well. But what if you have to use the substitution? How is this going to work? Now, the substitution that you have to use is u equals sine x. Let's write that down on the side here, u equals sine x. So in this integral, this sine x is going to convert to u. So you'll have u in place of sine x here. However, the idea of substitution is that every variable that you have in this integral that is in terms of x, so every expression that's in terms of x, you have to convert that to something in terms of u. So there should be no x in this integral, because otherwise you would not be able to integrate it. You can't integrate u with respect to x. If you want to integrate u, everything in the expression should be in terms of u, and your integration should also be with respect to u. So instead of dx here, you also need du. Everything needs to change to something in terms of u. Now, u equals sine x helps us convert sine x to u like this. We've changed that at least at this point. However, how do we change dx to du? This also needs to be changed to du. Okay. For that, whatever substitution you have given, you're going to differentiate it. You're going to differentiate it, and that is going to give you, in this case, du over dx equal to What's the derivative of sine x with respect to x? Derivative of sine x is cos x. So this is du over dx. And now what you do is you make dx the subject, so you know what you have to replace dx with. Okay, so you have to make dx the subject from this. That gives you dx equals du over cos of x. All right, that's what you do here. Now let's just input this substitution in this case. So in place of sine x, what we're going to do is we're going to input u. So it becomes u here. In place of dx, we are going to input this whole thing, which is du over cos x. Once we are done with these two things, then we'll think about if there's any x that is still left, we can see what to do with that after that. But let's just input these two things first of all. Use the substitution that's given, that's one thing, and find dx and see what you have to replace dx with. In this case, you have to replace dx with du over cos x. Let's do that. You have cos x here as it is. Dx has to be replaced with du over cos x. Now it turns out cos x and cos x get cancelled here, and you're just left with integral of u with respect to u, and you've got everything in terms of u now. U needs to be integrated with respect to u. How do you do this integration? Integral of u is just going to be u squared over 2. All right. You increase the power by 1, add 1 to the power, divide by that increased power. That's the rule that we're using here. Just like integral of x is x squared over 2. In this case, the variable is u instead of x. So integral of u is going to be u squared over 2. All right. And then now once you're done with this, you put that substitution back. Okay, you put that substitution back because the original integral that you're integrating, that is in terms of x. So you have to convert it back to something in terms of x. Now, u was sine x. So this is going to become sine square x over 2. That's the integral of sine x into cos x. Sine square x divided by 2 plus c. That's how you integrate this. All right. Now let's take a few more examples on this to understand how it's going to work in different contexts. Let's say we have to integrate something like this now. We have 2xe raised to the power x squared plus 2. We need to integrate this with respect to x. Okay. Now, this is something that is actually going to be pretty hard to integrate using integration by parts. The problem with that is this thing is something that you do not know how to integrate. E raised to power x squared plus 2. Why? Because the power is not linear. The power is not linear. We could only integrate something like this if the power was something linear. Integral of this would be e raised to power ax plus b divided by the derivative of the power, which is a. In this case, the power is not linear. So we don't know how to integrate this. All right. If you were to take this as dv over dx, it would not simplify because v would be 2x squared over 2. It will start getting more complicated. Using integration by parts is not helpful here. Okay. So that would not work. So in a situation like this, in a case like this, what they would do is they would give you a substitution. So in this case, for instance, they will tell you to use this substitution, u equals x squared plus 2. Okay, so they will tell you to use the substitution. This will be given there. They will always tell you what substitution to use. Okay, so let's say they've given that you should be using this substitution, u equals x squared plus 2. Now, how do you go about it? X squared plus 2 is right here. That can be replaced with u. That's one thing that you can do. All right. And then you need to think about how to replace dx. Forget about everything else for now. Forget about 2x. We'll figure out what to do with that later, or it might just get eliminated itself. For now, just focus on the substitution that's already given. U equals x squared plus 2. So in place of this thing, you put u, and you have to replace dx with du somehow. For that, you differentiate u equals x squared plus 2. Let's see what the derivative of that turns out to be. Du over dx. What's the derivative of x squared plus 2? That is 2x. And now you have to make dx the subject, so you can replace this dx with that thing. If you make dx the subject here, dx is going to go there, 2x will come here. So that gives you dx equal to du over 2 times x. This is dx for you. You replace it with du over 2x. Now, let's do the substitution and see what we get from that. 2x remains as it is. We're not going to do anything for that for now. E raised to power x squared plus 2, that gets replaced with u. So you have e raised to power u here. Okay. And then dx gets replaced with du over dx. So in place of x squared plus 2, we are inputting u. And in place of dx, we are inputting du over 2x, not dx. It's du over 2x. Okay, so that's what you do here. And now you notice 2x and 2x, they get cancelled automatically. So this 2x gets cancelled with this 2x. And you're just left with e raised to power u with respect to u. This is something that you can integrate now. We have everything in terms of u. What's the integral of e power u? It's just e power u. It remains as it is. Just like the integral of e power x is e power x. When x is the variable, in this case, u is the variable. Integral of e power u is just e power u. Okay, so this is the integral that you get. Now you replace u back with whatever it was in terms of x squared plus 2. So the integral turns out to be e raised to power x squared plus 2 plus c. That is the integral that you have. All right, so that's how substitution works. You have to do two things. You'll have u equal to something given. It's going to be given to you. Okay, you differentiate it and make dx the subject. Once you've made dx the subject, you replace dx with that thing as well and see if there's some cancellation that is possible. And mostly everything will convert to u automatically once you do that. All right, and that's how the substitution works. Now let's make it slightly more complicated. Let's say we have another example. And that looks like this. So this was the previous one. If you want to have a look at this whole thing, this is what we did here, okay? Let's move on and take another example. Let's say we have to integrate 4x into square root of 2x plus 1 with respect to x. And we are given that we should be using this substitution, u equals 2x plus 1. Again, remember, the substitution is going to be given to you. Okay, they will tell you what substitution to use. So they've asked you to use this substitution to integrate this expression. All right. Okay, now what do we do here? 2x plus 1 can be replaced with that u. Okay, so that's done. Now we have to think about this dx, how to replace this dx. For that, we differentiate it. Du over dx. What does that turn out to be? That's equal to 2. You have to make dx the subject. Make dx the subject, and that leaves you with du over 2. Just input these two things there and see what happens. Okay, so just input these two things and see what that gives you. 4x remains as it is for now. Inside the square root, instead of 2x plus 2x plus 1, you have u. So that gets replaced with u. Instead of dx, you write du over 2. All right. And the problem now is this x does not get cancelled. and this x is still there. All right, so this x is still there. What do we do with this? Now we could do some cancellation at least. So this 2 gets cancelled with this 4. We're left with 2 here. So we have 2x here. We don't know what to do with that for now. Okay, so we have a situation like this in which we have 2x into square root of u with respect to u. Now we can't integrate this function yet because we still have an x here. We can only integrate once we have converted everything to something in terms of u. All right. So now we need to think again and look at the substitution that we have. U equals 2x plus 1. How can we replace this x here? Or you could also just think of this 2x as a whole. If u is 2x plus 1, this gives us that 2x is equal to u minus 1. 2x is equal to u minus 1. And we could use this thing here to convert 2x to u minus 1. All right, we could convert 2x to u minus 1 there. Let's do that. And that leaves us with u minus 1 into square root of u into du. This is what we have to integrate now. We use that substitution. Now we have converted everything to something in terms of u. And now we could integrate this expression. All right. Now, how do we integrate this expression? It's a product. We might think of using integration by parts here, but notice we could just multiply these two expressions to make it simpler rather than using integration by parts. You could just multiply u minus 1 with square root of u. Remember what square root of u is? Square root of u can be written as u raised to power 1 over 2. So if you multiply, if you just expand this bracket, that will make things easier for you. U into u raised to power 1 over 2, what is that going to give us? U power 1 into u power 1 over 2. The powers get added, and that leaves you with u raised to power 3 over 2. Minus 1 into u raised to power 1 over 2, that remains u raised to power 1 over 2. This is what you need to integrate. You can just integrate these two expressions separately. What's the integral of u raised to power 3 over 2? It's a simple power function. Add 1 to the power, u raised to power 3 over 2 plus 1. That is going to become u raised to power 5 over 2. Divide by the increased power. So you divide by 5 over 2. Minus u raised to power 1 over 2. What's the integral of u raised to power 1 over 2? You add 1 to the power, 1 over 2 plus 1. That gives you 3 over 2. Divide by the increased power. So you divide this by 3 over 2. Now simplify this. This 2 is going to go to the numerator for both fractions. And that leaves you with two u raised to power 5 over 2 divided by 5 minus 2u raised to power 3 over 2 divided by 3. This is what the integral turns out to be. Okay, but now this is something in terms of u. You convert it to something in terms of x instead. So put that substitution back. U was equal to 2x plus 1. You replace u with 2x plus 1, and that gives you the final integral. 2 into 2x plus 1 whole raised to power 5 over 2 divided by 5 minus 2 into 2x plus 1 whole raised to power 3 over 2 divided by 3 plus c. That is what the integral is. All right, so this is how we use this substitution. Make sense? So that's the idea of integration by substitution. Now let's take an example on this to understand how this is going to be applied. Now, for now, we have only discussed how to integrate and get an expression in terms of x like this. Sometimes what happens is they give you limits with that integral and they ask you to evaluate that integral. So find some value of that at the end. So not an expression like this. They want you to evaluate that definite integral that has limits with it. So this is one type of that question. This is question number 10 from the worksheet. Let's have a look at this and see what we do with those limits. So we have I equal to 1 over x into 4 minus square root of x. That's the integral that we have to evaluate. And it says use this substitution to show that I can be written like this. Okay. Now notice here, the limits were from 1 to 4 earlier, and now they've become 1 to 2. Now let's see how that is going to work. Let's look at part 1 of this first of all. So the integral looks like this. We have to evaluate I, which is equal to 1 over x into 4 minus square root of x. Now, when they ask you to use a substitution, you have to use it. There's no other choice. You have to use what they're saying. They've asked you to use this substitution, so you should be using that substitution. Now, what exactly is the substitution? It's u equals square root of x. Let's write that down on the side here. U equals square root of x. That's the substitution that we have to be using here. All right. Now, the first thing we do is we differentiate it and find du over dx from this. All right. So we find du over dx from this. What does that turn out to be? If u is square root of x, that gives us u equals x raised to power 1 over 2. How do you differentiate that? That's going to be half into x raised to power minus 1 over 2. That's du over dx. Now let's write it like this. It becomes du over dx equal to 1 over 2x power 1 over 2. And then make dx the subject. If you make dx the subject, that gives you, so I'm taking dx to this side and bringing the 2x power 1 over 2 here. That is going to become 2x power 1 over 2 into du. This is one thing that you're going to be using. And this is the second thing. You have to replace dx with this thing. Now, what do we do after this? So we have u equal to square root of x, and we have dx equal to this. Just input those values here and see what that gives us. So right now, we have limits from 1 to 4. Now, actually, there's a problem here. Let's skip the limits here for now. Don't write the limits yet. And the next step, I'll explain why in a moment. In the denominator, we have x into, the square root of x could be replaced with u. So it becomes 4 minus u. And then instead of dx, you write 2x power 1 over 2 into du. All right, so we're done until this step now. So we've done that first thing. We've replaced u with the given substitution. All right, and we have found an expression that we can replace dx with as well. Okay, so once that is done, we think about the remaining x terms that we have. We have an x here, and we have x here. We could first simplify that. How is that going to work? This is x power 1 in the denominator. This is x power 1 over 2 in the numerator. We could write this as integral of 1 over x power 1 over 2 into 4 minus u. And in the numerator, this 2, I could actually write this 2 here. So this is 2 here, and then we have du. So what I've done is I've taken this x power 1 over 2 to the denominator so that it becomes x power minus 1 over 2, and then x power 1 minus 1 over 2, that gives us x power 1 over 2. All right, I've just used some indices rules here. This is what it gives me. Okay, and I still have this x power 1 over 2 here. Now I know x power 1 over 2 is exactly what u is, so I can replace this with u as well, so that it becomes 2 over u into 4 minus u, and we have something like this with respect to u. And now you have everything in terms of u, so now you should be able to integrate this. All right, so you first have to convert everything in terms of u. Once you're done with that, after that, you can try to integrate it. Okay. Now, why are we not writing limits here? Remember the limits that we were given here from 1 to 4, they are limits of x. We have the original integral in terms of x. So the limits that we have here are also in terms of x. So it's x equals 1 to x equals 4. That's what the limits are. All right. But when we convert it to something in terms of u, we can't input the same values in place of u here because those values were for x. So we also have to change the limits. So when we use a substitution, the limits also get changed. Okay, that is why these limits are different here. So how do you evaluate those limits? So you have two sets of limits here. There's a lower limit and there's an upper limit. Now it's important to write them separately because sometimes what happens is that the earlier lower limit becomes a bigger number. So 1 might give you a bigger number and 4 might give you a smaller number. So you need to make sure that what value corresponds to what value. So I would recommend that you write it separately like this. What is your original lower limit? The original lower limit is x equal to 1. That's the lower limit. All right. You convert it to something in terms of u. U is square root of x. That's the formula that you have that connects. That's the equation that connects u and x. What is going to be the corresponding value for u here? U equals square root of 1, which is just u equal to 1. This is your lower limit. Okay. Upper limit for x was 4 here. U is square root of x. So u becomes square root of 4 and u turns out to be 2 from this. That's the value of u that we have here. Now remember, we don't put plus minus here. If there was a plus minus, they would write plus minus here like this. Okay. When we take square root ourselves, so if it was, let's say u is square equals x and we were taking square root ourselves, then we would say u is equal to plus minus square root of x. But they've only written square root of x here. That means they're only considering the positive case here. This case here, they're not considering the negative case. So we will just write square root of 4 equal to 2 here, not minus 2. So these are the limits that you have from 1 to 2 for u. So once you convert it to something in terms of u, if you were to input the limits directly in this expression, the limits that you would be using here would be from 1 to 2. It's necessary to show this process where you are converting these limits because they've already given you the answer here that this is what you want to convert it to. Since the limits are already given there, the marks are going to be for the working that shows how these limits change to these limits. So you have to show this working, how x equals 1 gives you u equals 1 and how x equals 4 gives you u equals 2. So this working is important. You have to show this in the exam. And if you notice now, we've got exactly that thing that they asked us to show in the first part. Integral, the original integral that was in terms of x earlier, that has converted to something in terms of u, and that's exactly this form. We have also changed the limits. So this is what we had to show in the first part. Okay, so we have used the substitution and converted to a form that looks like this. So the first part is done. Okay. Now in the next part, you just have to integrate this function now. Okay. The next part is just about integration. In the next part, it says, hence show that I, which means this integral, equals half ln 3. So now you have to do that integration and prove that once you input the limits, it turns out to be half ln 3. Okay. So now you need to think about how to integrate this function. So this function is I equal to integral of 2 over u into 4 minus u with respect to u. How do we integrate this now? That's what we need to think about. Now it's a fraction. How do we integrate fractions? We have the log rule, right? For that, we need the derivative of the denominator to be in the numerator. The denominator is quadratic. Derivative of quadratic expression is linear. So that is not going to work. Okay. The ln rule does not work. The next rule that we had was tan inverse rule. For that, you need a constant in the numerator. That condition is satisfied. But in the denominator, you need something like this: a square plus x square, or x square plus a square in any order. Now you don't have that here. You have a minus sign, and you also don't have a constant. It's 4u minus u square. So that is also not going to work here. So log rule doesn't work, and the tan inverse rule does not work. So both of those rules do not work. What was the next option? Partial fractions? Well, yes. We have factors in the denominator. One is u and the other is 4 minus u. We would have to find partial fractions for this to be able to integrate this function. Okay, so we'll have to find partial fractions. Let's do partial fractions for this now. So we have 2 over u into 4 minus u. These are two linear factors in the denominator. Both are different. So the form is going to be a over u plus b over 4 minus u. Multiply this denominator on the left side and the right side, and that gives you 2 identical to a into 4 minus u plus b into u. Okay, now you input some specific values of u here. You could input, for instance, in order to make this 0, you could say, let's input u equal to 4. Let's start with that. If you input u equals 4, that gives you 2 equal to 0, because the first term is going to become 0, plus b times 4. And that gives you the value of b, which is going to be 1 over 2. All right, so that's the first value that you're getting. Now the next value you could input is, if you input u equal to 0, that would eliminate b. So let's put that. Let's put in u equal to 0 here. And that gives you 2 equal to a into 4 minus 0 plus 0. And the value of a here also turns out to be 1 over 2. So a and b are both 1 over 2. So we could say these partial fractions become 1 over 2 times u. All right, so originally you would have 1 over 2 over u plus 1 over 2 over 4 minus u. That's what it becomes essentially. Okay, so instead of integrating this original function, what you do is you integrate these two separate fractions. You integrate these two fractions separately. All right, so that's what you do. Let's try that. I is now going to be equal to integral of 1 over 2 divided by u minus 1 over 2, sorry, plus 1 over 2. So let's actually write them separately as well. You can just integrate them one by one. The second integral is 1 over 2 divided by 4 minus u. We need to integrate both of these integrals. Okay, so we could write them separately like this as two separate fractions. So rather than integrating this fraction, we are integrating its partial fractions instead. Okay, let's see what they turn out to be. This is a constant, 1 over 2. We could write this outside the integral. So it becomes 1 over 2 into integral of 1 over u with respect to u. Again, this is also a constant. We could write this outside. 1 over 2 into integral of 1 over 4 minus u. And now we need to think about what rule we can use here. 1 over u, what's the integral of that? That's just ln of u. The derivative of u is going to be 1. We have 1 in the numerator. So this integral is simply 1 over 2 into ln of u. The first one is pretty straightforward. Okay. What about the second one? 4 minus u is what we have in the denominator. What's the derivative of 4 minus u? Derivative of 4 minus u is minus 1. So if we had minus 1 in the numerator, we could use the log rule here. So what we can do is we can say, let's put a minus sign inside here. And to balance that, we also put a minus sign outside. All right. And now it becomes minus 1 over 2. And then the integral of this thing is just ln of 4 minus u. And that's your integration. And now you can input those limits. What were the limits? Limits were from 1 to 2. Let's input the limits and see what that gives us. 1 to 2. Now we could actually write half outside. That will simplify our calculation a bit. Again, half is just a constant. We could actually write it as half into, we could take half common and write it outside. So it becomes ln of u minus ln of 4 minus u. Okay. Before inputting the limits, this might be helpful because this would make your calculations relatively simpler. Now just input those limits. Input 2 first of all, that gives you ln 2 minus ln of 4 minus 2. That's what you get when you input 2. Subtract from that the case when you input 1, that gives you ln 1 minus ln of 4 minus 1. It's going to be ln 3. That is what you get inside. Okay, now let's simplify this. You have half outside. Inside, you get ln 2 minus ln 2 minus ln 1 plus ln 3. ln 2 minus ln 2, they get cancelled. ln 1 is just 0, right? So that gets eliminated as well. We are just left with half ln of 3. Now let's see what we had to prove. That's exactly what we had to prove there. Half ln 3, that the integral turns out to be half ln 3. And there it is. We've done that. Okay, so that's how integration by substitution works. Now let's take another example. Sometimes the limits end up being slightly confusing. Let's take an example on that here. Let me see if I can find an example like this. Yeah. Write that here. This is March 17, paper 3-2, question number 7. All right, let's try this. We have this integral given. We need to use the substitution u equals 5 minus square root of h to find the value of t. All right, let's integrate this. Now it's not the complete question. I think there was something else in the first part as well. So that's what these 3 marks are for. We're not focusing on that right now. Let's say that's done. We are not interested in that right now. I'm only looking at the second part in which we have to integrate this integral. Okay, let's integrate this and see what we get from that. So the integral looks like this. 10 over 5 minus square root of h with respect to h. That's what we need to integrate. The limits are from 0 to 4. The substitution that they've given is u equals 5 minus square root of h. That's the substitution that we have to use. Okay, that means in the denominator here, we could just write u in place of this. Okay, so in the denominator, you'll just have u. Now, what about dh? We need to figure that out. What dh is going to be replaced with. For that, we have to differentiate that thing. U equals 5 minus square root of h. That needs to be differentiated. Let's do that differentiation. Du over dh. What does that turn out to be? Du over dh. What's the derivative of 5? It's just 0. Derivative of minus square root of h. Remember, this means u equals 5 minus h raised to power 1 over 2. That's what it is. Let's differentiate that. Derivative of this is going to be minus half into h raised to power minus 1 over 2. Okay, we could write this as minus 1 over 2 into h raised to power 1 over 2 in the denominator. That's what du over dh is. Now we need to make dh the subject. Let's see what we get from that. When dh becomes the subject, 2h is going to get multiplied there, and that leaves us with minus 2h raised to power 1 over 2 into du. This is what we need to replace dh with. Let's do that and see what we get from that. Now, again, don't input these limits yet. We'll have to change those limits as well. We'll figure that out. Let's first just change the variables. We have 10 in the numerator. In the denominator, 5 minus square root of h is replaced with this u. So we have 10 over u here. Okay, that's the first part. Then, what can we replace dh with? Instead of dh, we can write this whole thing, which is minus 2h raised to power 1 over 2 du. All right. Now the problem is we still have an h here. What do we do with this? That's what we need to figure out now. Let's simplify this first. It might make things easier to understand. Minus 2 into 10, that gives us minus 20 divided by u. And we have h raised to power 1 over 2 here into du. We need to replace this thing with something. Now we go back to that substitution that we had. Let's make h raised to power 1 over 2 the subject here and see what that should be equal to. So this gives us h raised to power 1 over 2. If we take this to the left side, bring u to the right, that gives us h power 1 over 2 equal to 5 minus u. All right, that's what we get. So instead of h power 1 over 2, what we can do is we can input that substitution that we wrote there. So that it becomes minus 20 into 5 minus u. And in the denominator, we have u, and then we need to integrate this with respect to u. Now, everything is converted to something in terms of u at this point. Okay, so now this is something that we can integrate. We could think about how to integrate this now, but let's think about the limits as well. Okay, so first let's actually simplify this so that we make it relatively simpler to understand. Minus 20 into 5 is going to give us minus 100. Minus u into minus 20, that's going to give us plus 20u divided by u. This is what we want to integrate now. All right. Now we'll think about this. We'll come to this in a moment. But let's talk about limits as well now. Because the limits that we were originally given, they were supposed to be values of h. h equals 0 to h equals 4. They're the actual values. Now, what about the lower limit? Let's think about that. The lower limit here is 0. So the lower limit for h is 0. What about the corresponding value for u there? U would be equal to 5 minus square root of h. So that's 5 minus square root of 0. U turns out to be 5 from this. All right. What about the upper limit? The upper limit is 4. So the value of h there is 4. What's the corresponding value for u from this? U equals 5 minus square root of 4. That's 5 minus 2. And that gives you u equal to 3. And now notice the lower limit that you're getting here for u is 5. And the upper limit is 3. So be careful when you're writing these limits here. If you want to use the same limits as this, what you'll do is you'll write 5 as the lower limit and 3 as the upper limit. Don't interchange it just as it is. Okay, just thinking that 5 is the bigger number. Don't just write that on top here. 0 corresponds to 5. H equals 0 corresponds to u equals 5. So 5 has to be the lower limit here. And h equals 4 corresponds to u equals 3. 4 corresponds to 3. H equals 4 corresponds to u equals 3 here. So we'll write 3 as the upper limit here. Okay. So that is important. There is a way of flipping these limits as well, switching these limits as well. Sometimes they might ask you to show something. For example, they might ask you to show at the step that the integral converts to something like this, 20u, in fact, the other way around, 100 minus 20u divided by u with limits 3 to 5. Sometimes they ask you to show something like that. For that, you need to know a relationship that you can use to switch limits. Let me actually write that here, where we did substitution. Let me add that here. That's actually important. Sometimes when they ask you to show something like that, what happens is, if you have a function like this, f of x, that has limits from b to a, let's say, you could interchange the limits if you want. You could change the limits to a to b if you multiply this function by a negative sign, minus f of x. Okay? So if you want to interchange the limits, you would have to multiply with a negative there. For instance, if you have integral of x minus 2, and the limits are from 5 to 3, if you had to interchange the limits, if you wanted to interchange the limits such that the lower number is, such the smaller number is the lower limit and the bigger number is the upper limit, what you will do is we'll multiply this by negative, so it becomes minus into x minus 2, and then it'll be okay. You can switch the limits if you put a negative sign there. All right. The reason for that is when we evaluate this, we'll be inputting 3 minus 2 and then subtract from that 5 minus 2. All right. But if we use this, if we interchange the limits, in that case, we would end up getting 5 minus 2 minus 3 minus 2. So in order to get the same result as before, we have to put a negative sign outside. So when we interchange the limits, there comes a negative sign here so that these two become the same thing. Now, you don't necessarily have to change these limits. Sometimes they ask you to show a particular form. For that, if you need to change it, if you need to switch the limits, you can switch the limits using this rule that we have here, that you switch the limits and put a negative sign here. So for instance, in this particular case, if you wanted to switch the limits, minus 100 plus 20u, that would become 100 minus 20u. If you put a negative sign here, this becomes plus, this becomes minus, and then you could switch the limits like this. If you need to, if they had asked you to prove or show a form like this. Otherwise, it's not necessary. If you just want to evaluate the integral, you could just keep it as it is as well, and that's okay. You'll get the same result. So let's just keep it as it is for now because they don't ask us to show anything here. We just have to evaluate this. So we could just keep it as it is, just keeping in mind 5 is going to come here and 3 is going to be here. Okay. All right. Now let's integrate it and see what result we get from this. How do we integrate this fraction? Again, it's a fraction. Think about the rules that we have. Does the log rule work? It doesn't. The derivative of u is 1. You can't have that in the numerator. It's not the tan inverse form. You can't find partial fractions. There's only one thing in the denominator. None of those rules work. What else? Can you break down the fraction? Can you break the numerator down? That's going to help actually. If you break the numerator, it's going to become minus 100 over u plus 20u over u. So let's break the fraction down like this. Minus 100 over u plus 20u over u. All right. And now for the first fraction, you could write minus 100 outside. What are you left with inside? Just 1 over u. And for the second one, u and u just get cancelled and you're just left with integral of 20 with respect to u. Now, what's the integral of 1 over u? It's ln of u. That's what you get from the first expression. What's the integral of 20? If it was x, for instance, and you were integrating 20, integral of 20 would be 20x. Here, the variable is u. So the integral of 20 is going to be 20 times u. All right, so instead of x, you would have u here. Now, once you're done with the integration part, you input the limits and see what that gives you. Let's input the limits. Limits are from 5 to 3. Remember, 5 is the lower limit, 3 is the upper limit. Let's input those values. So we have minus 100 into ln 3 plus 20 into 3. Subtract from this minus 100 into ln of 5 plus 20 into 5. I just need to evaluate this and see what that gives you. What form do they want? Yeah, so they are just looking for the value of t. You just have to evaluate this, write the exact form, that's better. Let's see what we get from this. Minus 100 ln 3 plus 60 plus 100 ln 5 minus 100. Now, remember what I said earlier? Whenever you're evaluating integrals like this, the examiner wants that in your final answer, you have only one single log term. You should not have multiple terms. You should only have one single log term. Now, although they haven't really specified here whether they want an exact value or a non-exact value, so you could just convert it to decimals directly, and that would be acceptable in this particular case. You could just write this, you can just put this whole thing in your calculator, write the value that you get in decimals, and that will be acceptable in this particular question because they haven't asked you for an exact value. But if they had asked you for an exact value here, what would you do in that case? You would write the log terms together. So you have 100 ln 5 minus 100 ln 3 plus 60 minus 100, that gives you minus 40. You would write this as a single log term. You would not leave it like this if they had asked for an exact number. How would you write this as a single log term? To be able to use the log rules, the division law, the multiplication law, you want the coefficient outside to be 1. Right now it's 100. What you can do is you can take 100 common. That leaves you with ln 5 minus ln 3 inside. And you have minus 40 outside. Okay. And now on this thing, we could apply the division law. We have subtraction outside the log. Inside the log, it's going to become division. So it's ln of 5 over 3 minus 40. That's going to be the exact value that you get from this. 100 ln of 5 over 3 minus 40. In this case, you could just evaluate this in decimals as well. And that will also be acceptable. Just put this whole thing in a calculator. You could do that right here as well if you wanted. If you do that, if you put this in a calculator, that's going to give you 11.1, and that would also be acceptable. Okay, so in this case, both are acceptable, but if they asked for an exact form, this is what you would do in that case. All right, so that's how we use integration by substitution. Whenever you have to do this, they will always tell you in the question that you have to use substitution, and they will give you that substitution. Okay, so they'll always tell you about that. All right, now that's it for today. If you have any questions, you can let me know. We could discuss them. Tomorrow and the day after tomorrow is going to be mostly spent on doing some more practice. There's one thing that is still left, and that's another application of substitution. You sometimes have to integrate powers of sine and cos. Sine cube, sine power 4, cos cube, cos power 4. Similarly for tan as well. We will learn how to do that tomorrow, inshallah, and then we'll do some more practice on Thursday, inshallah. And on Thursday, hopefully, we should be able to wrap this up so that on Friday, we start with differential equations. Okay. You can also let me know if there are any particular questions from the worksheet or from any recent paper that you would want me to discuss. We could do that in class. But of course, you need to have attempted that first so that you know where you're having problems. We could discuss them on Thursday as well. You can let me know about them.